Hi everyone, today we are going to be looking over section 1A.3, which is dividing polynomials using long division. And I am currently on page 14 of my 1A packet. So, dividing polynomials using long division. Polynomial long division is similar to the numerical long division you learned in elementary school. So we're going to start with a very simple problem from elementary school, hopefully to jog your memory about long division. So in long division, this number here is called my divisor. So 3 is my divisor. The number underneath is called the dividend. And whatever I find up top for my answer is going to be my quotient. So let's get started with this problem. I'm dividing 7,492 by 3. So first I look at the 3, my divisor, and I find how many times does 3 go into 7? 3 goes into 7 twice. So I put a 2 up at the top. And 3 times 2 is 6. So when I say 3 times 2 is 6, now I'm subtracting down, and I have a remainder of 1. Once I do that, I basically repeat and I bring down the 4. Bring down the next digit. So now how many times does 3 go into 14? 3 goes into 14 4 times. 3 times 4 is 12. Subtract, and I have left over 2. Bring down the 9. How many times does 3 go into 29? It goes in 9 times. 3 times 9 is 27. Subtract, and I get 2 as a remainder. Bring down the 2, which is my last digit to bring down. 3 goes into 22 7 times. 3 times 7 is 21. Subtract, and I get 1. 1 is called my remainder. I know that 1 is my remainder because at this point, 3 can no longer go into 1, and there's nothing left to bring down. In the past, you may have added zeros to find decimals. So in this, we're just going to leave a remainder. And when you have a remainder, you write it as remainder over the divisor. So the quotient is 2,497 and 1/3. If you want to check that on a calculator will come out and give you 0.33333, which is the 1/3. So that's just a quick reminder of how to do long division in general. Below here, you have the formal definition of polynomial long division. And basically, this is just reminding you of the vocab words that I just pointed out in this problem. So you have the dividend, which is under here, the f of x, the divisor, which is out here, d of x, and you get a quotient polynomial q of x, which would be up here, but we're saying equals q of x. And then the remainder over the divisor. This one note down here, the degree of the remainder must be less than the degree of the divisor, is the information that you need in order to find out when you're going to stop. So I'm going to do example 1 and 2 in this Nearpod, and then we'll go through the other ones in class. So let's look at example 1. First, I need to set it up. So I'm going to set it up. I'm dividing x cubed plus 5x squared minus 7x minus 14. And I'm dividing it by x minus 2. So here is, I'm going to continually refer back up to that example that we just did. So x minus 2 is the divisor. I'm looking, the first thing I did up here is I looked how many times does 3 go into 7? So what's tricky about this is you have a binomial that you're looking at. How many times does it go into it? But what I really care about is how many times does x go into the first term in the polynomial that I'm dividing. So how many times does x go into x cubed? What I really mean to say is, what do I multiply x by in order to get to x cubed? Take a minute and think about that. So if you answered you multiply by x squared, you are correct. X times x squared gives me x cubed. If you answered you multiply by 3, 3 times x gives you 3x. You can't get an exponent just by multiplying by a constant. So think about that. So now once I find out what goes up here, the next thing I did is I multiplied my divisor by that number and put it down here. So I'm going to go off to the side and I'm going to multiply x squared times x minus 2. And when I do that, I get x cubed minus 2x squared. And so I put that under there. Now I'm going to add down, or not add down, sorry, subtract down. So I'm going to subtract this polynomial. When I subtract this polynomial, think back to subtracting polynomials. You have to distribute the negative sign. So this turns into minus x cubed, and this here turns into plus 2x squared. Because when I distribute, it changes those signs. So now when I subtract or add down technically, now x cubed minus x cubed, that goes away. 5x squared minus a negative 2x squared gives me 5x squared plus 2x squared, which gives me 7x squared. Once you get to that point where you have the remainder down there, now I bring down the next terms. So I'm going to bring down the rest of the polynomial here. Minus 7x minus 14. Now I'm back to the start. So I'm thinking, what do I have to multiply x by in order to get to 7x squared? So x times 7x gives me 7x squared. So now again, I go off to the side and do 7x times x minus 2. Gives me 7x squared minus 14x. Now I'm going to subtract down to see what's left. So 7x squared minus 7x squared goes away. Negative 7x minus a negative 14x turns this to plus 14x, and you get 7x. Bring down the minus 14. Now, keep in mind, I highlighted up here, the degree of the remainder must be less than the degree of the divisor. If you remember from the first page of this packet, the degree means the highest exponent. So the degree of the remainder is currently 1. The exponent on that x is 1. The degree of the divisor is also 1. So I'm not done yet. The degree of the remainder has to be less than the degree of the divisor. So I need this degree to be less than this degree. So now I'm still looking. 7x minus 14. How many times, what do I have to multiply x by to get to 7x? I have to multiply it by 7. So I put a 7 up here. Then I'm going off to the side. 7 times x minus 2 is 7x minus 14. When I subtract this, 7x minus 7x gives me nothing. Negative 14 minus a negative 14 turns this to plus 14, and negative 14 plus 14 gives me 0. So this technically means that there's a remainder of 0. And when there's a remainder of 0, you don't have to write it. So my final answer here is going to be x squared plus 7x plus 7. Now, in the future, you're going to learn about how when you have a remainder of 0, if you have a remainder of 0, that means that the divisor is a factor of the original polynomial. So this means that x minus 2 would be a factor of this polynomial. So my final answer is here. What I'd like you to do now is I'd like you to pause and try and set up example 2 and see where you get to. So pause, set up example 2, see where you get to. If you get to a point where you're stuck, let me know. If you get to a point where you get the answer, say what the answer is, and then you can play through and see how you did on the problem. Go ahead and pause. All right, so example 2, I'm going to go through. I have x plus 3 as my divisor, and you likely were able to set this up. I'm dividing x squared plus 4x minus 1. So first, I look at the x and I say, what do I need to multiply x by to get to x squared? X times x. Off to the side, x times x plus 3 gives me x squared plus 3x. And subtract down. Those go away. 4x minus 3x. So that's minus, and I have just 1x. And bring down the negative 1. I'm not done yet because the degree of the remainder is not yet less than the degree of the divisor. So I have to look at what does x multiply by to get to x? Just 1. So now I'm doing 1 times x plus 3. So that gives me x plus 3 under here. Subtract. X minus x goes away. Negative 1 minus 3. So that gives me negative 4 as a remainder. The remainder's degree is less than the divisor, so therefore I'm done, and this is considered the remainder. This might be where you weren't sure what to do. Negative 4 is the remainder. When I have a remainder, I write it as a fraction over the divisor. So since negative 4 is my remainder, my final answer is x plus 1. And then I write plus negative 4 over my divisor was x plus 3. So I have x plus 1 was from up here. My remainder gets written over my divisor. And then the plus sign is kind of like and this. So when I wrote 2,497 and 1/3, I could have written a plus sign. Since I'm writing a polynomial down here, I have to write a plus sign because just writing the fraction on the end wouldn't make sense in terms of polynomials. So that is polynomial long division. Make sure you come to class ready to practice and ask your questions.